we go. Let me see, does this work better? Is that better? Okay. All right. So this one has a lot of parts going on, okay? So I want to remind you that when we have inscribed shapes and you want that angle, this would be my interior angle, right? So to find B here, it's 180 minus I divided by 2. This only works because this is an isosceles triangle. Otherwise, that would not work. Okay. Morning. Next, we have this one, and this is good, a good study sheet entry, right? If you want to find that angle, you got to know that there's two interior angles there. So to find B, it's going to be 360 minus 2I over 2. Make sure you put that in brackets. And then the last one is a bit more difficult to do, but I think it can be done, right? If you want to find that base angle, that's why I use B, but you have to expect different letters, right? So that would be 540 minus 3I over 2, okay? So those are the ones that we most commonly use, but I might throw a hexagon at you, and then I would expect you to understand what would this number be for a hexagon. I don't know if your memory is maybe not as 720, right? Minus how many eyes? It'd be 4 eyes, right? And so forth. So keep that in mind. Pay attention now. Your hair can take care. You can take care of that later. All right. We've got this to get us started. That should be on your study sheet. That's inscribed. Okay. So where do you want to start? I'm going to start with this triangle down here, right? I want that angle D. So angle D is going to be 180 minus the interior angle of this big polygon divided by 2. So I actually didn't start where I was supposed to start. Okay. So I'm going to start with this one out here. That's the one you want to focus on. So we'll find the interior angle. Actually, angle A happens to be one of the interior angles. That's the one I should have started with. That makes most sense to start with. How many sides does this polygon have? Check mark, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n is equal to 11. Make sure you state that right from the beginning. So then it's 11 minus 2 times 180 over n. Okay, this is when you're actually finding the interior angle of that big polygon. This goes back to the formulas we talked about when we started with polygons. So that's 9 times 180 over 11. And what do we get there? I think that is 147.27. Okay, you should all have this one. I asked for it, so that means that it needs to be there somewhere and show work, okay? Next, I will continue with D here. Highlight A, like this angle right here is the one that's technically my interior angle. It is also over here. It's actually in every single corner of this polygon. Okay, so angle D is 180 minus this angle that I just found. That interior angle. All of that divided by 2. It's 32.73 when you subtract and you divide that by 2. Because why are we dividing by 2? Because now we're dealing with the diagonals. Okay, then that's when you start dealing with isosceles shapes. So we end up dividing by 2 after subtracting. Okay, so if we divide that by 2, you get 16.37 degrees. If you want to go 365, because that's what you get when you type that in, I'm okay with that. And I know in the past your teachers may have rounded degrees to whole numbers, but because it's so close here, we keep everything to 2 decimals. We don't round to whole numbers here, okay? Next, I'm going to solve for B here. Okay, and so for that one, I'm going to focus on the one diagonal there that forms the angle there at B. So this is a trapezoid here. It's a quadrilateral. So angle B, what do all angles add up in a quadrilateral? 360, right? Right, this adds up to 360. So to find B, I will have to subtract 2 interior angles and divide that by 2. Okay, so that would be 360 minus 2 times 147, 27, divided by 2. Right? So you go minus 2 times 147.27. Do this first. You get 65.46. Then you divide that by 2. Angle B is 32.73 degrees. Right, and now this is where questions arose here. To find angle C, there is a triangle, but please do not use more than one diagonal at a time. So I'm just going to stick with this one here. And then you have, if you follow that, 1, 2, 3, 4, 5, right? It's a pentagon here. I will write the pentagon along this orange line here. There's your pentagon. I'm going to cut this off here. And so to find angle C, it is 540, okay, minus 3 interior angles, all of that divided by 2. So as you can tell, everything depends on you finding the interior angle of that big polygon. This is 147.27 divided by 2. Angle C divided by 2. That's 49.095, so that's 10, right? It rounds to that. And there you have all of them solved. Just like that, okay? It's a lot of work, but it's grade 11 applied after all, right? So it should be, it's going to be work, and you have the calculator, so that should help you out. So that's the first part that I wanted to review. The next part is to make sure you understand when the dashed lines leave the shape, right? This is on 44. What do we call these angles right here? These are exterior angles, right? So gotta know that, and then you can work with the triangle. These are not diagonals, right? These are leaving the shape, not diagonals. This is a diagonal. These ones are not. So that's a review there. And then also don't forget about these ones. I'm going back a little bit. Some students may look at this one. This is on page 40. And sometimes because you just work with inscribed polygons, you might think, oh, this is a diagonal. I'm going to find it. No, don't do that. What is this? A is a central angle. It's a central angle. And B has several central angles in it. You just have to make sure there's 1, 2, 3 sides, right, from end to end. Therefore, there are 3 central angles that make up angle B. Right? So you got to know that part. So don't mix them up. Do not mix them up. Okay. Yeah.
How one angle has how B could be the central angle?
B is from here to here, right? It's that whole angle. But you can tell that there are 3 central angles that make up B, right? There's one central, another central, and another, right? So once you find a central angle, just multiply it by 3, and then you have B, right? Do you know your mystery angle strategy, the 4 pairs? Do you know those? You have it on your study sheet? Okay, corresponding. So these ones always need to be on your study sheet as well as just polygons in general. Remember, the sum of interior angles always works. So if you have like a weird looking polygon and you want to know what do all angles inside that polygon add up to, this is what you do, right? You figure out, count the number of sides, the minus 2 times 180, and then subtract the ones you know to figure out the rest, okay? These ones only work if it, I'm going to add something here. Can you go to E on page 33? Just say you can use this formula, or what's the other one for exterior angle? 180 minus I, right? I didn't give this at the beginning because I didn't want to add too many layers to this, but this one works. If you have the interior, you can find the exterior, right? It doesn't need to be regular. If you have the interior, you can find the exterior at that one intersection, at that one corner using this. If it's a regular polygon, then this works every time. They're all the same. And they always add up to 360, right? Before I give you the AC, let's go to 31. Would you be able to do that one? In 3 minutes. Try to do this one in 3 minutes. Explain, right? Have a justification. So tell me which one you're solving for first, right? Say angle whatever is equal, and then explain how you got that. This is on page 31. Try that one before we get started. All right, some of you are actually trying. That's good. How do I begin? I think what I would like you to really pay attention to is the fact that there are 2 parallel lines, right? And you travel along one of the transversals, not both, right? So if you traveled along this one and maybe move into that parallel line and then move into this parallel line a little bit, you should start to see, right, that Z shape that we're looking for, backwards Z or whatever you want to call it, but you should see that. So if this is 53, like I'm picking a number, of course, right? And then I'm looking, how does that relate to something on the other side of that parallel line, right? This is connecting the parallel lines. That's my transversal. So angle C might be a good start, right? You say 53 degrees, and it's because alternate interior angles are congruent. So you know that this is 53. What could you use now? This one you should be able to catch, right? It's a triangle. So even if you get this one wrong, right, your justification can still get you places, right? So F is going to be 180 minus 53 minus 44. What is that? Did anybody crunch the numbers already? 83? Okay. Thank you. It's too early for me to do mental math here and get it wrong on camera. 83, so that's sum of triangle is equal to 180 degrees. Got it. So we know that this is 83 here. What should we do next? Chandra, yeah. Vertically opposite, yeah. See how they're touching here? They're meeting here. If you have an X, okay, right, X happening, 83, 83, these are the same. So I'll do that one next. Vertically opposite. And we know they're the same, they're congruent. Okay. So that's 83 here as well. All right, what should we do next? A? What would you use for A? Same as F, sum of triangle, or you see that other transversal that connects the two? You see this one? You cut in, you cut in. Would that help us? Right, this is alternate interior as well, right? So you could use that, or you could use, I just hope that it works out. I gotta make sure. I'm gonna use sum of triangle here. Sum of triangle is 180. So let's see here. Should be 44 technically. So 180 minus 53 minus 83, that is 44. Okay, I did think when I was making this question. So it is 44 regardless of how you go about it. You can go or alternate interior. Write that down so you know that you have options there for it. Okay? B next. Okay, hold on. How would you find B? I see a triangle here, but you don't know D yet. So let's find D first. Okay? How would you find D? Chandra again. Straight angle. Yeah, there's a straight angle happening here between E and D. They're right next to each other. So I'm going to say 97. 97 degrees, and I just use straight angle.
Excuse me. To find B, we have to subtract the angle A from angle D.
To find B,
Yeah.
A and D, I would just say inside this triangle, since you know this is 97, that's 38, you take these two away from 180 to get B. So I'll go sum of triangle is equal to 180, and we'll just go 180 minus 97 minus 38. And that's 45 degrees. Okay, so now you know that B is 45 here. Okay. Is everything solved for? Think so. Yeah, I think we're good. All right. So this was maybe a bit of a tougher one because it's kind of sideways and we don't like too many lines crossing, right? But just try to highlight, right, parallel lines. Okay, this line connects to the other parallel line. Let's try to see what's there. How can we transfer information? And then the same with the other transversal. And then where they meet, right? Triangles get you to this intersection, and then you use vertically opposite, straight angles, all of those things to fill in the rest, okay? Okay, I'm gonna stop here. It's just like